In this lecture we'll talk about how we eliminate errors in a measurement. Okay, and basically we are going to talk about how we eliminate random errors. Okay, now suppose one student is doing one experiment and what he found is that he was measuring time period of a pendulum using stopwatch. Okay, and let us say he find out this measurement t1 2.3 second, as we all know that time period is time between time for one complete oscillation. So suppose he found out using stopwatch. Let's not go detail. Let us say he reported it like that. Okay, now how we are going to assess what is the true value of the time period. For that, as we talked or discussed in the last lesson, that true value means average value. So what he will do, the average value of this t mean he will find out to find the true value of the time period. For he has 5 observation, he will add all of them. And what you get is 2.624 second. Now you know from significant figures, if we are adding numbers, then I have to see which number have least number of significant figure after decimal, and my answer will be rounded off to that only. So after decimal you can see I have after decimal I have 2 places everywhere, so my answer will be coming up to that. So this is, I will drop this and I will round off. If I drop 4, I don't have to change this. If this number is 5 or if more than 5, then only we change it. So this is 2.62 second. This is the average time period, but this is also called true time period. Now suppose suppose he asks means how much this value and this value differ. Okay, so this is the true value. So t average is true value 2.62 second. Now next question suppose is how much by this and this vary. To understand that or to explain that, we introduce a concept of absolute error. In absolute error in any observation is in this first observation will be t mean minus t1. This is the absolute error in the first observation. Same way absolute error in the second observation will be t mean by, and so on. Okay, so if you calculate this, then it comes out that this is okay, this is in second only. Delta T4 is minus 0.09 and delta T5 is, if you calculate by same way, this will be minus 0.18. All are in second. Now, so absolute error in each observation is calculated like this, right? Now, you can see some absolute error are positive, some absolute are negative, but so absolute error can be positive or negative. Okay, but the word absolute means that everything is positive. So actually we'll discover that in error, in when we calculate something, error always gets added. So for that we calculate next something is what is called mean absolute error. So mean absolute error in this case will be calculated let us denote it by delta t mean is equal to delta t1 this is the calculation of mean absolute error. Now this two lines only represent these numbers are all positive. So when we calculate mean absolute error, we make everything positive of absolute error and we calculate it. So this comes out to be, in our case, this comes out to be delta t mean comes out to be 0.108 second. Now since we are now adding the numbers, so if you see all these numbers, the number we are adding after decimal place, in one case or in lot of cases we have one decimal place, one significant figure only. So my answer I have to report up to after decimal only one significant figure. So I have to drop this, and since I am dropping 0 I don't have to do round off. So this will be 0.1 second. How we got this? This is nothing but how we add significant figures, right? What is the rule of it? You will get this, that I have to report it up to this. Now there is also one error of interest that is called fractional error, and fractional error we calculate using delta t mean. This is mean absolute error by t mean. This is called fractional error, or this is also called relative error. Now the last concept what is asked in any error calculation or something, or generally, that is called percentage error. Now percentage error is nothing but delta t mean by t mean, and this is in this you have to multiply it by 100%. Now let us just do the calculation. So fractional error in our calculation will be t mean is 0.1, 2.62. So this will come out to be 0.0381 second. Now again, when we divide, there is a rule how you divide significant figures. So when we divide, we see which one has least significant figure, and our answer should have that much significant figure. So you can see this has one significant figure, this has 3. So our answer will be, I have to report it to one significant figure because this has least significant figure. So I will drop this 8 here. 8 should be dropped. Now I am dropping 8, so it will increase by 1. Concept of rounding off, 0.04 second. Oh sorry, this will not have any unit, it's a ratio of second by second. So fractional error or relative error is this much. Now how much will be that in percentage? You guys all can see that this is 0.04. If you multiply by 100, so you will be 4 left. So reading 4%. Now how you represent this calculation? Okay, so how you will report your measurement in this case? So you will report your measurement as we mentioned in the starting, that any measurement should be written like a average or a mean plus minus delta A This is uncertainty. So we are going to write the representation or the result, let us say result like this: T mean plus minus delta T. So this is 2.62 and plus minus T mean we have calculated 0.1. This is the representation of it, and if you express this in percentage, sometimes you can write 2.62 plus minus 4%. Now you all can calculate 4% of this. Okay, 4% of this will come out to be this only, but generally it is either represented like this, or 4% here only means that 4% of this, okay, which is 0.1. Now this is the representation. Now the next idea what we are going to discuss is in a measurement how error play a big role. Or let us take a simple example. Suppose I have some length L1 and some rod length L2, okay, and let us say actually this is L1 plus delta L. There is uncertainty here also, and there is uncertainty here also. So if I have a two rod of different length and different uncertainty, okay, let us say this, then if I join them, what will be the total uncertainty, right? That is called addition of error. Then suppose now we have two temperature, higher and lower, and I want to find how what is the error in difference in temperature. So there is an error in the first reading of temperature, second reading. If I subtract it, how error plays a role there. And then suppose there is a error in length and breadth, right? If I find area, how this two error adds up. And suppose I have error in, let us say, distance measurement and time measurement, how error will play role in calculation of velocity. So whatever I said can be summarized is into how errors add or subtract, and how error multiply or divide. So two things are very important: how error comes out when we do measurement, okay, involving two or more things and both have error, how they evolve actually. So this concept is called propagation of error. Propagation of error. Now if I have error in addition or subtraction, how error will add up. If I have error in operation in multiplication and division, how error will add up. Now in case it turns out that for addition and subtraction rule is same, and for multiplication and division rule is same. So in the case of addition, suppose I have one reading L1 plus delta L1 and L2 plus minus delta L2. Suppose these are two readings. So if I join these two lengths, then this will be L1 plus L2 plus minus delta L1 plus L2. This is true for adding. Okay, so same thing can be generalized to different thing. I took the example of simple pendulum where I have took 5 observation. You may have 10 observation. Now in this case we are adding two lengths, right? You can add two lengths, you can add two masses, right? You can add two volumes, all the scalar quantity you can add. So how error adds? So this is the first length, let us say this is second length. If I join the two rods, okay, so this is rod length and this is the second rod length. If I join them, error will add up. Now in this case, maximum fractional error, okay, which is of important, percentage error in addition comes out to be delta L1 plus delta L2 by L1 plus L2 into 100% in case of addition. Now same thing, of course I have to take different numbers. Now let us say we have a temperature, okay. For subtraction we are saying, suppose we recorded temperature and first temperature is this one and second temperature is this one. Let us say we recorded temperature of two things and it came out to be this. Now if I have to calculate the increase in temperature, what will be the error in that? Now it turns out that when I subtract this two, okay, then I will have if I subtract this 2, then I will have T2 minus T1, or you can write T1 minus T2 also, it doesn't matter, I am just assuming this is more than this, plus minus now what is odd here is that in subtraction also error is added. Now this is very important to understand that when you are subtracting two things, let us say two temperature, one has some error, second has error, just imagine if you subtract it, why error should be subtracted, right? Error is some uncertainty, it will always get added, error is always added, okay. In case of when we calculate all these things, we'll find out error will be added. Okay, now this is the catch here, fine. So please try to understand, if I subtract two things, error will get added in it, okay, it will not get subtracted because there is an error. If you do subtraction or addition, in both cases error will pile up, okay. If you subtract two things, it will not just go away. Now let us talk about now multiplication and division. Okay, before going there, in this case the fraction percentage error is calculated by this formula, delta T1 plus delta T2 by T2 minus T1 into 100%. This is the percentage error in case of subtraction. Now let us come to multiplication and division. Now to take an example, let us say we have an area and let us say length is L plus delta L and breadth is B plus minus delta B, okay. Now if I have to calculate area is L into B, right? Now how, if I calculate area, this error will add up, okay. So I am not going to write this is the basic formula, length into breadth, but how, when I calculate area, it will add up, so it will get multiplied, right? So in case of multiplication, it turns out that fractional area by area will be equal to delta L by L plus delta B by B. In multiplication, the error, this is a fractional error in A, this is fractional error in L, and this is fractional error in B. The fractional error in area should be written like this, fine. Now this may look odd, but means right now it is the God, okay, means let us just understand it, it's getting added. Now percentage error, what you do, you just multiply this side by 100% and whole thing into 100%, so that will be the percentage error. Now let us talk about last concept, let us say division. Now let us say we are measuring distance, and distance came out to be this with some uncertainty, and time came out to be this. So we are trying to measure speed, right? So speed is distance by time. Now if I calculate speed, how error will propagate or how error will evolve if we divide two things, okay, division. It turns out that in this case, let us say speed is v, delta v by v is delta d by d plus delta t by t. Same formula as that of multiplication, that this is the max fractional error in speed, fractional error in distance, fractional. Again, in all the cases, just pay attention, everything is getting added. I know that means you can ask that from where from here to here came. You guys will learn that, or maybe I will tell you guys later using logarithm. I guess you guys can do that, but right now you just pay attention that error always get added. Now all these things, multiplication and division, can be written in a general form. So if you have a function like z equal to p x q r and s y, okay, let us say x z. So if a quantity is written like this, okay, there is a multiplication also, division also, what is the fractional error in this? So it turns out that fractional error in z is this, and that is equal to x delta p by p plus z delta q by q plus y delta s by s. This is, so this power, again you can again ask from where to where you will get this. So the answer is, using logarithm you can do that, and right now you just see this power multiplied by the fractional error in this. So the take away, okay, this, if you pay attention, then division and multiplication goes by the same way only. So the takeaway is this, that error always get added. We can eliminate random errors. There are ways to calculate error, right? And this the way the error evolves, right, in addition or subtraction or multiplication or division, is that in everywhere they get added, but they get added in a particular way. Okay, if you see the calculation of fractional error in the case of multiplication, division and this and that, you'll find out there is a difference, right? Now in the next video I will talk about, or I will solve some questions of errors, right?